So it's time to look at a particular type of class, and that is referred to as a static class. Most of the classes that you will write will be dynamic classes. And by dynamic, that means that you need to create an object of a class in order to use it. So an example of that would be the die class or the multi-die class that we've seen so far. The string class is also a dynamic class, although it does have a little bit of static class within it. But essentially, it's a dynamic class. You have to create a string object in order to figure out the length and do toUpperCase and so on. But there is a static class that we've seen so far, and that's the math class. So if you see here, we've seen math.squareRoot and math.min, math.max, math.random, math.sign, but we put the word math in front. We don't create math objects. We just go ahead and say math dot. This is a static class. And the lecture notes, as you see here, that goes on for a bit with talking about static and so on, but I thought it would be good to just take a simple example and just talk about creating your own static class. That would be much more informative and actually let you get a good idea of how to use this. Most of the time, a static class is defined for one of two reasons. Number one, it's going to store particular information, and those would be within variables, and we've seen that with math.py. It holds the value of pi. You don't need to calculate pi every time. Depending on which formula you use, pi might be inaccurate. So at least the value that's within the math class is relatively accurate to a certain number of decimal places. You can also use a static class to store particular methods that you find useful. But the methods don't interact with each other. There's no relationship between them. And that would be perfect for a static class. This we refer to as a utility class. So generally speaking, we've seen the utility class there, which is like the math class. It's got all those math methods within it. But you can also store your own methods in that as well, the ones that you find useful and you want to use often. So let's actually go through and define our own static class. So a static class is based on the term static. And in programming, something that's static is usually defined as something that's always available, which means you don't have to particularly declare it, you don't have to define it, it's already there. Also, there is only one of them in the computer's memory. Now, that's a little strange term, but there's only one of them. It just means that whenever you refer to this static, whatever it happens to be, not only is it always there and you don't have to define it, there is only one copy. You don't create multiple copies. For example, the math class is referred to as a static class. When you say math dot something, there is only one math class. There is no math object. You don't create 17 math objects like you would create 17 string objects. There is only one math class, and that's the one that's referred to. So that's what the term static implies. It's always available, which means you don't have to declare, for example, a math object, and there is only one. So whenever somebody's program refers to math.py, they're referring to the same math.py. And in your program, no matter where you refer to math.py, it's always referring to the same one. This means for a particular class that an instance is not required. So you don't have to declare it. You don't have to create an instance of it. And that applies to whether it's a variable or a method. So math.py is a static variable, whereas math.min is a static method. So when we're using the term a static class, what we're really going to imply is that everything within this class is also going to be defined as static. So that's all the variables, all the methods, everything will be static. If there isn't one thing that's static, and it would just happen to be one thing that isn't, it's not referred to as a full static class. In that case, because we have things that would be somewhat dynamic, we might have some things that are static, that would be referred to as a hybrid class. Now, a hybrid class, we've only seen one example of it, and that happens to be the string class. 99% of the string class, most of it, is dynamic. You need to create a string object in order to use string methods and manipulate strings, except in one circumstance. When you use string.format, if you want to format a piece of data similar to how systemout.printf would work, but instead of displaying it immediately, you would like to store the output, whatever the format happens to be, you would like to store that in a string. So you can use string.format. The fact that we're putting string in front, we're not declaring a string, we're just using the class name string, implies that that's static. So the string class actually has at least one static instance, or one static reference, if you will, to that particular method. So the string class is actually a hybrid class. It has a bit of dynamicness, most of it, and it has this part which is static. So the string class is very special. But we've already known that. The string class is magical. So it's going to break a lot of rules on its own. But generally, if we have a static class, everything within there is static. So we've seen some examples, of course. Every program you've ever written so far has been a static class, which is why we put in public static void main string args. That static is telling us that that main method is always there. We don't have to do anything special to the class. We don't have to create an object of this class. We just need to run it, because the main method, it's always there. And there is only one main method. It just happens to be the one that's in the class. So every program class you've written has been a static class. We've got some utility classes as well. The math class itself is a static class. You just use math.py or math.min, math.random, math.anything. You just use the name of the class and then dot with whether it's a variable or a method that follows. So the math class is also a utility class. You can also create your own Swiss Army knife class, and we refer to that as basically a utility class. So anytime we're using the term Swiss Army knife, it's because it's got all these cool little features, but they're always available. You just pull it out when you need it and put it back in, essentially. You don't have to create an instance of a Swiss Army knife to use the Swiss Army knife. You just go ahead and use it. So we're going to define our own utility class. So what could we put into this utility class that we're going to create? So we can put anything in there. Like, there is no limitation. It's up to you, whatever convenient little feature you want to put in there. But as an example, I've put some here on the screen. So we've got the some math and science constants. So pi, we've seen that in math.py. So we're just going to ahead and use that one. We're going to use math.py. There's the square root of 2. So it's one of these irrational numbers. So there's an approximation for it, 1.414, so on and so on and so on. The Avogadro's number, so the number of moles per liter or something like that. So that actually has a common reference. You use that in chemistry and I guess physics sometimes. We've also seen already some very useful static methods. So we've seen display and display line, input string, input word, input int, and all of those. And one of the exercises that I've had you do for methods is called multi-concat. It's actually a really cool little method. It lets you repeat a string over and over and over again and return that as a brand new string. So if you wanted to create a string of stars or repeat the name Bob over and over again, you could do that really easily with multi-concat. What makes them static is that these methods, and I guess if you will the constants, don't rely on each other that much. Display and display line do, and input string and input word and input int might rely on each other, but they're going to be within the same class, so they don't rely on anything outside themselves. This utility class is going to use one of the ideas we've been talking about for object-oriented programming, encapsulation. They're going to encapsulate everything that has to do with input string, input word, input int. It's going to encapsulate it within this class. Multi-concat encapsulates it within the method itself, also within the class. And this becomes your own, your personal utility class. So that's also a level of encapsulation. These are the methods and the values that you decide to be in this class. Nobody else has asked for them. You've found them useful. You're going to create your own utility class. And this is something that you can do as a programmer. If you're going to be in programming in Java for a long time, it wouldn't hurt to build up your own utility class. You've got these cool little methods, and you can use them when you're writing very small tester programs. This isn't something that you would want to write for your entire career. But when you're debugging and when you're writing short little programs, instead of having to type in systemout.println every single time, it'd be great to just say display. Also, if you're doing input and you're asking the user for something and there's an integer that's coming in, instead of having to do a systemout.println of the prompt and then declare a scanner and then input the integer with a scan.nextInt and store it to the integer, it would be much easier to just say input int and pass in the prompt and an integer comes back, because the input int method does all the work for you. So this is a great little idea to create your own utility class. It lets you write very short, very small little programs and lets you test an idea very, very quickly. So we're going to take a look at how we actually write it, but also how to call it. So before we get to the code, two very important things you need to do. Number one, pick a name for your utility class. So in this example, I'm just going to call it util. So it's a great short little name, very similar to math. I don't want to make this name too long because after a certain point, I'm going to get tired of typing it in. But just util is a very short name and it's very easy to remember. All my constants, so if we go back over here, we've got our math and science constants. We're going to declare those as final, which means that they can't change, which makes sense. Pi is always going to be pi, Avogadro's number is always going to be Avogadro's number, and the square root of 2 is the square root of 2. These values do not change. We could add in one more, which could be the gravity constant of the Earth or the Moon. So these gravity constants don't change, or at least won't change in our lifetime. So how do we go ahead and call them? Well, when we call them, we just put the word util in front. That's the name of our static utility class. So just like the math class, when you said math.min, we just put util dot in front. So as you see in the example there, if we wanted to pull out the square root of 2, we could just say util.root2. In this case, I'm using it in a formula, multiplying it by 5, and I'm storing it to the value of x. So I'm assigning it there. For this one, I'm using my input string method. So I'm just going to say util.inputString and then call it as I normally would. And Java should be able to find the class by its name alone. As long as, and as we've seen, as long as that utility class is in the same folder, the same directory as the program that's using it, we don't have to do anything special. There's no import that we have to do. We can just go ahead and use the name dot something. And it's really easy. And now our programs will actually start looking like more advanced Java programs. But really, are they? Not so much. We're just adding some extra syntax in there, but we're really just making our lives easier. That's the whole idea. So let's take a look at writing our own utility class and see how it pans out. So here I've got the beginning of my utility class. So I'm going to do an import java.util.scanner, and that's because I'm going to be doing some console input. For my input string and input int, I'm going to have to have the scanner class. But, and this is interesting, we won't have to do an import of this class in our program class that will be testing it. So I've already started over here the utility tester, and this is where I'm going to test some of the methods and some of the constants. I'm not going to have to do an import java.util.scanner because this class only has what it needs in order to function. And if the input string or the input int method is in this class, it's the one that needs java.util.scanner, not the program that's actually calling it. So that'll be something interesting when we take a look at it. So you'll see I've already got my two constants in there. I've defined them as public because I want to be able to reach into them outside. I'm going to be saying util, which is the name of my class, dot pi. So I want to be able to reference it outside. So I have to make it public. I'm making it static because that's the point. I want my value of pi, my variable here, to always be available. And I'm going to have to make it static. Now, because these are constants, I'm also making them final. I don't want another programmer being able to change the value of pi in the utility class. I mean, it doesn't make any sense, but I'm going to enforce the rule. This is my class, this is my security rule, and I'm going to make sure that pi does not change. Also, you'll notice that both of these are in uppercase. That is the convention in Java. Anything that is a constant is in full uppercase, so that another programmer, when they see the syntax, when they see this syntax here, actually I should make a correction. There we go. When they see that syntax, they should know that that is a constant just because it's in uppercase. So I'm following some Java convention. So I've got my value of pi, and I'm reaching over to the math class and just grabbing math.pi. I'm cheating a bit, but really I'm a lazy programmer, so I'm going to make sure that util.pi is going to follow the same math.pi value. I don't want to recalculate it, so I'm just going to steal it, if you will, from the math class. I've got my root2 value as well, and I've just manually put it in there. I've declared both of these as double. So there we go. I've got my two constants in there. Now, what about looking at some of the other methods? So I've got our display and our display line. Well, let's go put in display and display line and take a look at what that seems like. So they're going to be public again, and they're going to be static. And in this case, for my display method, they're void. They don't return anything. So let's see, display, that's going to be a string parameter at the beginning with a prompt. And what this does is it just echoes back the string systemout.print method. So that's really all this is doing. Let's change that from prompt to message, because I think that's the name that we had before in our examples. So I'm just going to display message. And then I've also got my display line method, so that's also void. And in this one, if you remember, we wanted to do some fancy method calling. So instead of using systemout.println, I could just go ahead and call my display method up above, pass in the message, but also concatenate a new line. So I've created a brand new string there by concatenating the message with a new line at the end, and that goes ahead and displays a new line to the screen. So there I've got my two methods, my display and my display line, and I've got some values. Let's just see how these will work right now. So I've got my tester program here, and the first thing I could do is actually just do a very simple display. Let's use a display line. So sample utility tester. Let's just see if that actually works. So if I compile this, what Dr. Java as an IDE, as an environment, will actually go out and check to see if util also needs compiling. The fact that I've got them loaded up in within Dr. Java tries to compile everything. And we've seen that example before where we have one program that's not complete, we try and compile another one, and Dr. Java complains about the incomplete program. So in this case, I'm just going to get back over here in my util tester. I'm going to compile it, and what is it complaining about? Well, it's complaining that it doesn't understand what display line is because it doesn't know where to find it. Display line is supposed to be within this class as far as Java is concerned. We need to put util in front, which is the name of our utility method, so that Java knows to reach over into this method, find which method to, or in this class, find which method to call. In this case, that one's not going to match. It's called display line. It finds this method, and it goes ahead and executes it. And because it's static, it is always going to be there. We don't have to do any special declaration. So let's compile this now and see what happens. Compiles just fine, which means it found the method. And let's run it, and there we go. We see sample utility tester. So it was able to find the display line method. This is actually pretty cool. So let's go ahead and display some of these other values. Let's go ahead and display pi and root2. So I'm going to go down here, call my utility method, and use my display. And then I just want to quickly just say util.py. I'm just going to display util.py. Now this will probably cause an error. Let me compile it, because what Java is telling us is that the double cannot be converted to Java lang.string. If you remember, with the display method, go back over here, we only have a display of a string. We don't have a display of an integer. So there's two things that we could do. One, we could actually add another one here, public static void display, and pass in this case it would be a double. So let's call it val. And what we could do is just call display again, concatenate an empty string with val. So now we have an overloaded display method. So we're using some polymorphism here. So we have a display of a string and display of a double. So over here we've got display, and if we compile it, now it's happy. The other way we could have solved this is not have had this method here. We could have just avoided it. So if we delete this method, go back over here, we could just concatenate this with an empty string. And that would be the exact same effect. So we'll leave it at that. There we go. So now if we run it, we should see a sample utility tester, and then we also see the display of pi. That's actually pretty cool. So let's go back over here. What else did we want to add into this program? So if we go back over to our utility class, we wanted to add in the input string, input word, and input int. So let's go ahead and add the input string. So public static. Now the input string method returns back a string. So we're going to have that as the return type. And we also had a prompt that gets displayed. So this was one of the methods that needs the scanner class, and that's why we added the scanner class up here. So we're going to create a brand new scanner. And attach it to system.in, and we will also display our prompt. So we're using our display method up here. Now you'll notice with the calls to display, we don't have to put util in front. It's not necessary to put util in front because all of these methods belong to util. So they're like brothers and sisters. They can see each other just fine. Nothing would hurt if we actually did put util in front, but we're lazy. We're not going to type something we don't need to. So we've displayed the prompt. Now we're going to get the input, and let's say we're going to store it. So this would be the string that's going to store the user's input. Now for input string, remember we did the entire string. So that was going to be a scan.nextLine. So we got everything the user typed in. And then we just returned that string. And that's the end. So let's take a look at what that how that example would go. So string, we'll just call it input, and we'll get that from the user. So enter a phrase, and then we'll just display it back to the screen. Let's see. Input was the input. So we have to remember that we're calling it from the util method. And there we go. Make sure I put in that period and compile this guy. So what we should have is sample utility tester, display the value of pi. Then the program will pause while it waits for me to type in a phrase. So we're getting something from the user, and then it's just going to display it. So there it is, a phrase. So the phrase, I'm just going to put bumblebees. If I can spell it right, there we go, bumblebees, and we display bumblebees. So you can see how short this program is. If we had to declare the scanner, declare all the various strings, do systemout.print or systemout.println, this main method would very quickly start getting very large. But because we're able to use the utility methods that we've created in our utility class, and this is where all the heavy work is being done, somebody still has to do it, but we've just passed it over here, we don't have to include the code. And we don't have to include it at any point. So if I wanted to declare an integer, let's see, integer value x util.input int, enter a value, and then I wanted to display it. And then I'm thinking, I don't have an input int method, but I'm going to just go ahead and write it into my utility class, because I don't want to add all that extra code into my main method. I mean, I'm already testing out my cute little program. Why put all that extra work in there? So I'm just going to quickly add my little method in here. This one returns back an int. We're going to call it input int. We have the prompt getting passed in. Now with the input int method, we can actually go ahead and use this input string if we wanted to, or we could just do all the work manually. And in this case, I'm feeling super code lazy, so I'm just going to copy all this stuff and put it in here and display the prompts. And in this case, it's going to be an integer. Call it ret. We'll do a next int and return ret. There we go. Because I can't spell prompt. So let's get back over here. So I'm going to enter a phrase, bumblebees, enter a value, everybody's favorite value, 42. And there we go. And you can see that this program didn't really get much larger. The main method is still pretty short. We've just added the complexity into our utility class, and we can use this utility class over and over and over again. It doesn't always have to be used by the utility tester method. It could be used by any program that we write. So the utility method is just like that Swiss Army knife. We can use it over and over and over again. And one little thing, just as I was thinking about it before we leave off, could we write an input int method that didn't declare all the scanner stuff? And yes, we could. And if you remember previously, what we did was we had a method in there called input word, which only entered one particular word. It wasn't the whole line. So that was just with next. So we just returned that string. What we could do in here is we could return back, if you remember, we'd use integer and use its parseInt method. And the parseInt method parses a string. And what we're going to do is get the string that comes back from input word. And that's where we pass in the prompt. So now our input int method is just using this one command, which then calls input word to do the actual heavy lifting of asking the user for information. So we'll just do a full compile of everything all over again. Enter a phrase. I'm feeling a little French, bumblebees, and then enter a value 42, and the main method works perfectly fine. So one final observation, even though we changed the input int method down here, we didn't have to actually change any of the code in the utility tester, in this main method, because it was rather oblivious. All the work that's happening in this class, in the utility class, is black boxed. It's encapsulated. Another programmer doesn't have to know how any of this code works. All they need to know is the API. What is the API? Essentially this. In my class, I have something called display, display line, input string, input word, input int, and then the multi-concat. We missed that one. Give me 1 second, and what we'll do is we'll write the multi-concat. So what I've quickly done is gone over here to my utility class, and I've added the multi-concat method. So the multi-concat method returns back a string. It has 2 parameters, which is an original string, whatever string it happens to be repeating, We have a value of n, which is the number of times to repeat it. So we could repeat the string 7, 8, 1 times, if you will. Within the method, we're going to have the return string. Initially, it starts off empty. We're going to have a simple loop, which basically counts from 0 to just less than n. So if n was 5, it would go 0, 1, 2, 3, 4, essentially counting 5 times. Within here, we're just going to keep concatenating the original string to ret. So if we had an example of saying we had the string yt, and we're going to repeat it 3 times, what we should end up with is the string yt, yt, yt. So that should be the effect of this method. So it's actually relatively innocuous and also pretty cool. So I've commented out all the extra code in our tester because what's the point of asking for strings and numbers? I just want to test my multi-concat method. So I'm going to call it from my utility class. It's called multi-concat. We'll have the phrase bees, and we're going to repeat it 5 times. And then we'll just display it. So what we should see is bees, 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 and bees, all as one big massive string. So let's take a look at what that looks like. And there's our bees, 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 bees. Fantastic. And the beautiful thing about a method like this, if I wanted to repeat that string 50 times, and let's put a new line in there. So every time it displays the word bees, it goes bees and a new line, bees and a new line. And what we should see is 50 bees. Hopefully we don't get stung. Yes, I know, that is a very bad joke. So there we go, we've got our 50 bees, and if we go back up, and if you can count really quickly, there were 50 bees in there. So the beautiful utility class method. Now, keep in mind, one of the most important things about the utility class, all of these methods and all these identifiers here, these constants, they are all static, which means they always exist. I don't have to declare a utility class object to actually use them. But let's say I wanted to. Because we can use the idea that the string class presents. The string class is a hybrid class. It has both dynamic methods. It also has at least one static method, which is string.format. So there is nothing stopping us from creating a utility object using all the syntax we've seen so far, and then using our utility object. In place of the dynamic or the static class name. So let's compile this. And you can see it runs perfectly fine. There's nothing in here. We have not enforced any particular rules, and I don't know if Java even has them, to say that you can't actually create a utility class object. So we could actually do that if we wanted to. It would be a little bit strange, but there's no reason to actually do that. So if it's a utility class, the idea is that everything is a static, so we just go ahead and use the name of the utility class, just like the math class. Perfect. So for the next virtual lecture, we're going to look at the puppy class. So this is a full dynamic class. It's got everything a dynamic class requires, and it is probably the most intense thing you've seen so far, maybe in the entire course. If you can understand the puppy class, you can understand how everything we've been doing so far will actually work. So it's a great example to work with. All right, see you in the next virtual lecture.